I'm going to use this opportunity to teach you about some really weird molecules that you're going to see the rest of Orgo, and maybe this will give you an opportunity to get a little bit more familiar with them. Alright, so let me go ahead and introduce these molecules first. We've got pyridine over here. He's like an all-star. Pyridine is like looks like a benzene ring. I know we haven't been over that yet, but that's a benzene ring with a nitrogen. Alright, very commonly used in reactions. Then on top we've got DMSO. DMSO looks a lot like acetone, except that it has a sulfur instead of the carbon. Okay. Then we've got THF. It's called tetrahydrofuran. You don't need to know the full name, but it's basically just an oxygen in a 5-membered ring. Then we've got carbon tetrachloride. That one is a carbon with 4 chlorines all around. The polarity is going to be interesting for that one. And then we've got basically just a sulfur compound. Basically, that's called a thiol group. And then we've got nitrogen, which has basically 3 carbon groups around it. Okay. And for these two, we're going to wind up having to draw Lewis structures to figure out what the solubility is. So what I want you guys to do is go through all of these and tell me if you would expect them to dissolve in an aqueous or be miscible in an aqueous solution. Okay? Now what aqueous means, it's not that tricky, but aqueous just means water. Okay? So what I want you guys to do is think about the polarity of water. Think about, is it polar or is it apolar? And then look for dipoles on these 6 molecules. Once you think you've found if they have a dipole or not, a net dipole or not, then you can draw your conclusion, is this soluble or is this not going to be soluble? Alright? Now for the last 2, like I said, you are going to have to draw proper Lewis structures in order to know if it has a dipole or not. Okay? Because it can get a little tricky if you don't draw the Lewis structure.